Welcome to Fire Sprinkler Systems Basics. My name is Steve Jackson. I was the fire inspector for Central Kitsap Fire and Rescue for 7 years and fire code technician for Clallam County Fire District number 3 for over 5 years. Plus I have 25 years of experience in fire alarm technician and fire sprinkler technician, along with several others. This is going to be a program designed specifically to give you at least the minimum things you need to understand for working with fire sprinkler systems on emergency runs, and also the enough information to be able to take care of systems that are in trouble or whatever you need to do. But it is for your knowledge. I highly recommend that everybody try to learn something new, at least one a day, and build up your repertoire of knowledge. And this will be hopefully helpful to you on fire sprinklers. Fire sprinkler systems are designed to suppress a fire shortly after ignition and contain it until firefighters can arrive and complete the fire extinguishment. It is to suppress, not to extinguish, and that's something to remember. They're not designed to extinguish. They're designed to wet everything down or as much as possible and hopefully hold the fire back so it doesn't get too far out of control, making it easier to contain and hopefully much safer for our firefighters. The sprinkler systems are not considered a life safety system by anyone except the sprinkler industry. Underwriters Laboratory, Factory Mutual, and the International Fire Code all say that this is not a life-saving system, and we'll get into that in the next slide. But except for deluge sprinkler systems, all fire sprinklers require heat to activate an individual sprinkler. There might be enough heat that you end up activating more than one, but each sprinkler is an individual activation and will only activate when the temperature surrounding it reaches its set point. Fire sprinkler systems do not sense anything but heat, and therefore, since smoke is the greatest killer in a fire, the majority of fire deaths are from smoke or vapors generated by the fire. Here's an article from NFPA explaining that a little bit further. We'll give you a chance to read through that before we move on. At the bottom of this slide in blue is the internet link to the NFPA article. You can read it and get more information from that. The numbers vary throughout different records and assessments made, but death by smoke inhalation, vapor inhalation, lack of oxygen is as high as over 80% in a lot of studies, and in other studies it's 60 to 70%. So there's a wide range of what it is, but it by far kills more people in fires than anything else does, or the rest of it combined itself. Getting into sprinklers, fire sprinklers, make it easier. We're going to break it down into 3 sections. First section is the water source. Water source could be anything from a pond with a pumper or a river with a pumper to quality PUDs like Clallam County PUD or Sequim Water Department PUD. where they have a good supply of water and at a good pressure, and their hydrants have good fire flow. But if you have water, you still have to get it on the fire, and so we have a sprinkler. Sprinklers take the water that's sprayed onto them, and they break it up and spread it out so it covers wide areas. But to get the water to the sprinkler, you have to get it there somehow. In the old days, that was done by this route. As you can see, they are quite slender firefighters in quite good physical condition. But in our modern day, we'd like something a little bit more reliable, so we have pipe connection and control valves, or riser. Riser gets its name from the fire alarms or the fire suppression system that comes up out of the ground normally, comes up through the floor, goes through all its valves and everything else, and then goes overhead, so it rises in the building. However, there are quite a few around that come down, especially if they're in basements, then they'll come down instead of up, but they still have the nickname riser. There are four main types of systems. We have a wet system, which means that there's water in it from the front end all the way to the sprinkler, which when fuses, then water comes out the sprinkler. We have dry systems. Dry is wet from the supply all the way to the clapper valve, which is held shut by compressed air, and therefore that's why they call it dry. There's no water between the clapper and the sprinklers. That comes about when the sprinkler fuses. The air bleeds out, the water pressure overcomes the dropping air pressure and floods the system with water, and it becomes a wet system at that point, spraying out. Dry systems are used mostly in areas that like to freeze, and outdoor patios, under canopies, things like that. Home Depot has had 3 frozen lines that broke outside because they didn't get them drained in the last 5 years. That's what the dry is for, and later on we'll get into how to prevent that. Pre-action, there's only one that I know of in our fire district. It is in on the second floor in the admin building for the county PUD on the corner of Hooker Road and 101. It works the same way, or as a combination between the wet and the dry. It's wet up to the clapper, and then it's dry all the way up to the sprinkler. But what they do with it is they tie in smoke detectors, and when the smoke detectors go off, then that's the incipient stages of fire, and so they trip it, and they force the clapper valve to trip open, so water floods the system, so it's ready to go if a sprinkler does fuse and activate. If it doesn't, and it's able to contain the fire, the smoke, whatever, and get it taken care of before it gets that hot, then they save putting water on their computer system, which will destroy the computers and their databases. So pre-action systems are generally kept in computer rooms and other sensitive areas to water. And the last one of the 4 is deluge. I've only seen one in my career, and that is at Indian Island. It's on the assembly line for the mines that they take out and drop in the water. They have a pull station at each workstation. It activates, if something happens, they pull it and it activates a fast speed, high volume pump that comes up and pumps water straight through a large pipe with large orifice sprinklers, and they don't fuse. They're open. So when that thing kicks on 15 seconds later, you've got water shooting out all over the place and literally deluging the place. This is the normal condition of a wet system. You'll see the dark blue is the PUD water. The light blue is the system pressure sitting there. And then we have the different parts of the system. Just above the words wet system is an OS and Y valve. It stands for outside stem and yoke. And that stem is grooved and spiraled so that when you turn the handle, it pushes the stem down, and the gate then goes into the pipe and shuts it off. You have a test valve, which is normally closed. You have the clapper, which is normally closed, and you have a pressure switch on top of the retard chamber, and the pressure switch is what sends the alarm to the fire alarm panel. What occurs is when the clapper lifts, as in this condition, then water comes out the little port on the right in this picture and runs through the piping into the retard chamber and fills it up, and then pressurizes the switch at the top, which then notifies the fire alarm panel that they have an activation. Retard chambers came into play when in the early 1900s, when they had a lot of false alarms. People shutting hydrants too hard, shutting any water supply system too hard, where it would send a shock wave, or it would water hammer the suppression system, and the clapper valve would lift, and the pressure wave would go on in and activate the pressure switch. So they put the pressure switch at the end of a retard chamber, and now it goes in, and the retard chamber has to fill up. It'll buy up to almost 60 seconds. Most water hammers will last 10 to 15 seconds, if that, so it will absorb that shock and never let it get to the pressure switch, so it cuts back on, quote, false alarms. And you'll notice that you also have, in this particular one, which is an older version, you have a system pressure gauge and a supply pressure gauge. We'll look at new systems here shortly. This is an old system. It's in the basement of the new building at St. Luke's Church, right down just north of Station 34. The retard chamber is round, which is unusual. They're usually elongated, but it's round. There are no switches to monitor it, so this is purely mechanical. It will not notify the fire department automatically. Somebody has to hear the water gong or see the water spray and call it in. And there's no valves. There's a drain valve is all there is, and there's no other valves to shut off the supply valve and so forth. This is not code compliant by today's standard. It was when they built it, however long ago, but it is unusual in that sense that it's the only one I've seen that does not meet the current code. It has two gauges, one on top, one on bottom. And if you look at them, the bottom one is about 80 to 85 PSI, and the top one's a little over 100 PSI, and that's what happens with water hammers. The water hammer hits and will lift the clapper valve, and when the upper portion equalizes and the hammer subsides, then the higher pressure that is now above the valve shows the valve back down and actually helps hold it. And sometimes technicians will do that on purpose to help hold that clapper down so that it doesn't bounce easily. Now on the right here is the old system, on the left is a new system, and there's some definite changes. On the right you see the red valve with the two gauges, that's the clapper valve. There is none on the left. You see two gauges on the right, there's only one gauge on the left. The flow switch is the red box, rectangular box, fairly up high, with the flex conduit coming out of it, and that's a paddle switch, so that when water flows by it, it pushes that switch to where it sends the signal to the fire alarm panel, and it calls the fire department. Here's some changes. On the right, the yellow are ones that the old systems had, and the new system doesn't. In this particular system, on the left is a paddle switch. On the new system, on the right, there isn't any. And even on that type of system, it would have been a pressure switch above the retard chamber, but this one on the left, the new systems, are paddle switches. And it has one gauge. You don't have a clapper valve, so you don't need to worry about pressure on either side. This is a flow switch or a paddle switch. It has a paddle that the water moves, so that fits inside. The U-bolt clamps around the pipe and holds the switch assembly to the pipe, and you can see it in real action. If you look below or the bottom left or on the right hand side, you can see the big rectangle. You can see the U-bolts. That's a very fast way to tell that it's a wet system. Dry systems don't use a paddle switch. They use a pressure switch, which are the little red boxes, which we'll get to soon. But what happens is the paddle switches can be adjusted from 0 up to 60-second delay before they actually activate the alarm. And so you could set those. We should set them for 45 seconds. Most water hammers are 10 to 15 seconds. So it'll subside back and go back to normal, and you never have a false alarm. This is a OS and Y. You can see on the side of the label there, it says OS and Y SU-2. That's an outside stem and yoke supervisory, and 2 has 2 circuits on that inside that little box, so you could hook up more than one item to it. It's a 3-position switch. The normal position is in the middle. If it goes too far one way or the other, it goes into abnormal and sends a supervisory alarm to the monitoring company, which then is supposed to call the maintenance folks to come out and fix their system. On the right hand of that picture is a built-in supervisory switch into a valve. And this one has the little yellow vein on it, so that when that lines up with the pipe, you know that it's open, and when it's 90-degree perpendicular to the pipe, it's closed. And water can't get through. And it is supposed to notify the fire alarm panel, which is supposed to notify the monitoring company that it's closed and you need to get somebody out here to check it immediately. This is a backflow preventer along with 2 OS and Y valves, gate valves, for a system down in Florida. It doesn't freeze in this area, so they can put these things outside and not worry about it. But that gives you an idea of what an OS and Y valve looks like. That's the stem standing up. And that stem, if the valve is closed, that stem is all the way down. If it's up, then it's open. It has the tamper switches or supervisory alarm switches mounted on it that go to fire alarm panel through flex conduit. And they also put chain and a lock on it to physically lock it. And that is 2 options. You have to do one of them according to code, and they chose to do both. But you either have to physically make it stay open, or you have to electronically monitor it to see if it has a change of status or state. This is a dry system, and the switches on the right, the little red boxes, as you can see, are quite different than the flow switch. And they have the little black threaded coupling that they screw into the black iron piping. If you look at the upper left picture and the lower left picture, you can see the black iron piping coming out. There's specific ports on a clapper valve. These screw in, come out. And then if you look at it, the one in the bottom right, its number is a PS40-2. That's a pressure switch 40 with 2 circuits. If it goes over 40, then it goes into alarm. And we'll get into that because there's 2 of those on a dry system. One monitoring the alarm, the other one monitoring the high air and the low air. Here's another system. Clapper's different. That's that black thing in this one. It was blue in the previous. And you see there's 2 gauges to the left. And they give the PSI on the air. They give the PSI on the water. And then you see the 2 little boxes, red boxes up above. One of them is high-low, and one of them is an alarm switch. These are the gauges up close. I'm going to give you a few seconds here. Take a good close look at the gauges and tell me what you see, or write it down on a piece of paper. If you look at it, the top one, which is the air, is reading about 42 psi. The bottom one, which is the water supply, is about 120 psi. So how does 40 pounds of air hold back 120 pounds of water? Well, that's basically the ratio that is used in figuring out with these clapper valves. It's about, for every 1 pound of air will hold back 3 to 4 pounds of water. So The one fast way to tell if a dry system is tripped is to look at the gauges and look at the air side. And if it's reading the same as the water side, then you know that the valve's tripped open and it is equalized on both sides of the valve. The problem with these gauges is that the water is, since it's 120, they have a 300 psi gauge in it. Since the air is around 40, they only have an 80 psi gauge. So when it equalizes, that top gauge can spin and peg out and actually do damage to the gauge. So just something to note. But it should go up. If it equalizes, the top one will be pegged and the bottom one will basically still be about the same it is now. But that'll tell you that a dry system has been tripped. This is an older dry system. It has a plunger handle on the right-hand side, that brass shaft with the black knob. And you can reset it without having to take off the cover plate like you did with the black one and the blue one. Tyco is the only one that made these. But you can see that there's a difference in the pressure gauges quite clearly in this picture. This is both the dry system we just looked at previously and the wet system we looked at previously of the new ones that are being installed. The left riser is the wet system. The right riser is the dry system. They both come off of a common manifold which comes in from Squim PUD. This happens to be Rock Plaza. And the football is left over from the owner's son who made this into his little apartment until I filed a concern with the city, since this is not a residential at all. But here you have a common manifold coming in. You have a valve on the left, and then you have a silver thing, and then a valve on the right, and it goes into the black manifold. That silver thing is a backflow preventer to keep the water supply clean and not get this dirty pipe water into the drinking system. But that's what it looks like. And on the right, on the dry, it stays dry because of the air that's compressed into the system. And so if you follow that red hose, looks like a garden hose, you can see it goes to a little compressor that's piggyback on the black pipe. It uses the piping of the system itself as its reservoir. It does not have its own tank and does not have its own reservoir. And that is quite common nowadays also. This is available to look at along with the fire alarm system. Bob Torres is the manager, property manager for that, and he has given us permission to go in and check that out. I would encourage the officer that decides to go visit with his crew to contact Bob Torres and before going out to Rock Plaza to make sure he knows at least that you're coming out to look. He's been extremely cooperative over the last many years. This next slide is a picture of a newer system, even newer than the Rock Plaza, but it has a wet system on the left and a dry system on the right. And when you look at it, you can see that on the left, there's a single gauge. There is the flow switch with the U-bolt clamp bracket holding it onto the black iron pipe. And that's all that there is a flow switch and a gauge. And then, of course, a valve, the one with the blue handle and the red box mounted on it for control valve. It does have a drain, which is the blue handled lever one that's sticking straight up. You open that and you'll get water flowing out the drain system. The one on the right is a dry system again, and it has the one switch, which is the alarm switch, is on the bottom left, sticking out horizontally. The high-low switch is on the top right, where it's monitoring the high and low pressure air. If too much air is put into a pipe, then when a sprinkler fuses, it can't actually trip the clapper and get water to the sprinkler in the 60 seconds required by code. To test these, we go to the furthest most remote sprinkler, and they usually is a sprinkler, open sprinkler that's just outside the wall for testing. And we go out there and one at the controls, and the guy who's timing it goes 1, 2, 3, go. The guy in the field flips that lever handle, then radios back immediately when the first water comes out. And it has to be less than the code allotment. And if it's not, then something's wrong with the system, but normally it does, and it'll trip the system and go. The compressor on this one is a black hose that comes off at the top right, and that's where the air is being fed in. The reason for a low air pressure alarm is the clapper trips on low pressure, and it's a lot of work to reset it. So it has a low pressure that when that goes into the monitoring company, they're supposed to notify the maintenance people to get out there right away and secure the system until they get it fixed so that they don't trip the system and get a false alarm rolling fire trucks, and also creating a whole lot of maintenance issue. This backflow preventer is directly beneath the two risers off the manifold, and they chose to lock it up with a chain and lock instead of paying for a monitoring switch, or two of them for this. So you have the master key in that red thing that's really long. This is actually part of the fire alarm system, but it is the interface between the sprinklers and the alarm. It's understanding how it works becomes another tool for you to figure out what's going on. The right picture shows the insides. The right side, that row of 6 screws, terminals, is where 2 circuits can be hooked up. The 2 screws on the left is a computer database linkage that takes it back to the fire alarm panel, which nowadays is basically a computer. The addressing for each number is those little orange dipped switches in the black window there. And you tie these in to the flow switch and the tamper switches on a sprinkler. And this slide you can see 4 of them in the background. One of them actually I can see 5. 2 of them partially hidden by gauges. These, when they're pulled, P-O-L-L-E-D, will flash a light, letting whoever's watching know that the computer talked to them. When they go into alarm, most of them will go into a solid red or yellow or green light, usually red, and it locks on solid. They're supposed to have labels on the little face plates, and you can read that and tell exactly which one it was supposed to have activated. This slide's out of focus. It's another one off the internet, but I chose it because it's the only one I've seen where they've actually taken and stacked all of these little boxes in neat little rows. All the others they've stuck right behind the risers. Then it also brings up a different one, but here you walk in and you look at it. You have to look at the label to see which one's red and tell which riser it is. This one has 3 risers that are smaller and 1 riser that's bigger, but only out of the 4, only 3 of them have control valves, main shutoff valves. The 4th one, which is the 3rd from the right or the 2nd from the left, going right, and you also notice that that one doesn't have a gauge on it. Well, actually what it is, it's an extended part of the manifold. It goes up to the overhead and out, and somewhere out in the field is a dry system. Though it's easier and cheaper to run water than to run air that far, and a compressor big enough to pump it up and powerful enough to keep it up. And the cost of maintenance when you have to take the system down and then wait for it to pump up. Plus, once water runs through a pipe and then it's kept dry, it has a bad tendency to rust. So it cuts back on maintenance, both installation cost and the maintenance. So they choose to do this. Home Depot has done this, but they've done it slightly different. They've taken one of the regular wet systems, so it has a control valve at the manifold like these other 3 do. But it goes out in the field and it goes up the west wall right next to the nursery, and it gets up to the northwest corner of the building, inside the building, and then it drops down to a dry system. And it has wet sprinklers along the way, but at that point, the wet system drops down and goes into the dry clapper valve, and the rest of the system in the nursery and the canopies and around back outside are a dry system. And that's the way they save money also. So that's what we're looking at, but that's just another way of doing it. These are wall-mounted PIVs, post indicator valves. You see the little window? That's the indicator telling you it's open. These have to either be locked open, secured open, or they have to be electronically monitored. This is both. This is on the southeast wall outside of Michael's. It feeds, they share a common sprinkler room between Michael's and what used to be Ulta. So to shut off a sprinkler system in what used to be Ulta, you have to go over here to shut it off on the PIV to shut off the system inside, or you have to go inside Michael's to shut off the riser and to reset it and so forth. So they put them all in one room, but they actually feed two different buildings. I directed them to put addresses on the valves and on the back doors. They wanted to put names. I asked them what happens when one of them moves or goes out of business. So we need addresses because addresses aren't changing. So they wanted the names, so they put them on. And sure enough, Ulta is now out of business, but at least the address is still on the back door and on the valve unless somebody has changed it. These work just like any of the other valves. They're just mounted on the wall. This is a PIV, a post indicator valve. They're usually away from the buildings, and they do the same thing. They have a window that you can see open or closed. That takes, on both of these styles, it takes about 20 turns to get them open or closed all the way. This one on the top left corner is quite old. It's been painted numerous times, and the painter doesn't care what he paints, so everything's red. But the wrench has a lock on it, so people don't steal it and they don't play with it. And then it also has the electronic or electrical monitoring device hooked to it to see if it's moved. The whole thing with PIVs and WIVs is you can shut down the entire system from this point into the building by using these. In the bottom right picture, you can see where they're using a PIV to actually feed a fire hydrant. I'm guessing that fire hydrant's been hit a few times, and so they need something to shut off that water to the hydrant with. And this one is a cute idea. Firefighter or chief retired and had a friend in the business who gave him an old PIV, and he put it in concrete and mounted his mailbox on it. And that is definitely unusual and a talk of the town. Now we'll get into dry systems. Dry systems are more complicated, and I'll walk you through it. I do not expect you to operate them. You can secure them wet and dry by turning off the control valve or the water supply valve. All the valves are supposed to be labeled, usually with a sign hanging on them so you can find them easily. But if you find the manifold and look at the riser coming up off the manifold to the valves, then you will see a valve in that line that is the supply valve. You can turn the water off to it. In this one, the water pressure is dark blue again. The air pressure, though, is the light blue. And where there's no pressure, or it's atmospheric pressure, is white. This is the OS and Y, or main shutoff valve, or main control valve. Those are all three common terms. And then you have a tamper switch that's mounted. This is an OS and Y type, so the switch is mounted. The stem goes down and rides on the stem of the stem of the switch, rides on the stem of the valve. And when it's in the groove it's supposed to be in, then everything's happy. But if it's pushed out of that groove, or the switch is taken off so it swings the other way, then it sends in a tamper warning to the monitoring company, and they're supposed to get somebody to come fix it. This is where the air compressor goes on a dry system, and it feeds in to the upper part of the system. It builds up pressure there. There's also a little priming chamber there, and that's partly when you reset these things. The clapper valve is that yellow valve, and you have to open up the port on the left-hand side and reach in there and shove that down and make sure it's set. Then you put the cover back on, you pour in a cup full or a container full of water and bleed it in there, and it fills it up, and it helps seal it, and it helps preserve it so because it's sitting in water instead of air. The top switch is a high-low switch. We talked about that. If you get too much air, it won't bleed off as fast as it's supposed to. If you get too little air, then it is liable to trip too easy and get a false alarm. And then we have the alarm flow switch. If the clapper valve lifts, that yellow thing, on the left-hand side you'll see a little cup. And out of that cup comes a line that goes through that red valve, and then up to the alarm flow switch. So when that lifts, the water comes through and pressurizes that switch, which is at atmospheric pressure. So when it jumps to the 100 and whatever is in the system, or 90 or even 50, it'll activate that switch and call the fire trucks. This is the alarm test valve. If you once every 3 years, you have to actually flow water and test it. So you go out to the most remote sprinkler. Usually a test valve is put there, and you open it up and you see how long it takes to trip. But the other 2 years, you can check just to make sure everything else is working. You're allowed to by NFPA, but you can do that by using the alarm test. You open that one up, and it just takes water straight out and straight up to the flow switch to let you know that, yeah, the electronic side of it is working. And we're going to assume that the water side is doing its thing properly. This is the main drain, this line coming down. And of course, that's the main drain valve. You open that to drain the whole thing off. You first need to shut off the control valve, the OS&Y main shut-off valve or main control valve. Otherwise, you're just going to be running water out of the PUD straight into the street. So you shut the OS&Y off, and then you can drain that. That shouldn't be your problem, shouldn't be your issue, but that's what the parts are. And then we have the alarm line. In the alarm line we talked about earlier, the yellow clapper goes up, water comes out, runs through the alarm line, and hits the alarm flow switch and activates the fire alarm system. Sprinklers. Now, sprinklers are what the code calls the device that spurts the water out, that sprays water. Sprinkler heads and heads are commonly used, but technically the word is sprinklers. I'm going to try to stick to the word sprinklers. That does not mean a sprinkler system. It means the individual sprinkler, and that is a common misunderstanding even among some of the technicians. Sprinklers are designed to cover this, I should say the standard sprinkler, are designed to cover an 8-foot diameter before water drops 18 inches. And that's based off of water flow and pressure and so forth, all engineering things that have to be gathered for the site before the system's designed and installed. And they have all sorts of computer programs that make that easy. But if you go out into the meeting room up front in Station 34 and you look up and you count the tiles, you'll see that there's a sprinkler head about every 8 feet in a grid pattern. That's because each sprinkler will cover 4 foot around it, and the next one will cover 4 foot around it. But 18 inches beneath the deflector disc is the code requirement to keep all storage and other stuff down. Otherwise, it obstructs the spray, and if the water can't get to the fire, then it can't suppress it. So this is where the code comes from, is the design on sprinklers. This is an old-fashioned fuse type sprinkler. The link plates are held together by a specific degree melting lead or solder. So they solder those link plates together at a metal material that will melt pretty close to the degree that they want. It's plus or minus 10 degrees air. They hold the two levers together, which then applies pressure to the cap and disc to hold the water back. And then, of course, the deflector makes the water go out in a spray pattern that's desired. So when the solder fuses, very much like a fuse in a car when it blows, it gets hot enough that it melts. Then those two link plates cannot hold the two levers to get pieces of lever together, and they spring-loaded and they jump right out of there, and that allows water to push the disc and the cap out. And now all those loose metal pieces are on the floor, and water's squirting into the deflector disc so that it can be distributed as designed. These are large bore sprinklers. They're large drop. They're designed for putting over high rack storage, such as Home Depot, Costco, warehouse area of Walmart, and some of the storage facilities out in the Carlsberg area. This is the newer style of sprinkler heads. You have what they call a frame. They also used to be called a harp because of the shape of them. They still are by some people. But you have a deflector that directs the pattern of the water. You have the frame that holds it all together. You have the sealing assembly, which is what seals the water off using the temperature-sensitive glass bulb. And the difference between these glass bulbs is temperature and the rate of response. A quick response bulb has a 3 millimeter bulb versus the standard response of 5 millimeter. So the 3 millimeter breaks quicker than the 5 millimeter does. You look at the color code and you can see what you tell what temperature it is from just looking at it from the ground. Red is the most standard. It's 155 degree Fahrenheit, and but they go all the way up and down. And there are some that go even higher than the 360 that's listed here. Here are different types or styles of sprinklers. A conventional upright is in the top left corner. A upright is in the top center. A pendant is hanging down. Now the uprights have a umbrella or a deflector that when the water hits it, kicks it out sideways, and then the fingers kind of guide it into a spray pattern. So they go out and they drop down. The pendant goes looks upside down. It's hanging. And when it breaks, the water shoots straight down. So all it needs to do is be dispersed in the pattern they want. So its fingers are kind of like blades on a propeller. They have a slight twist to them so that it makes them explode into tinier pieces or tinier droplets and spread out better. Horizontal sidewall is used an awful lot in apartment complexes where if they put the sprinkler in the middle of the staircase, it usually gets hit by furniture being moved in and out, and so they put horizontal sidewall. It gets it more out of the way. The top flat plate on that helps direct it, kicking it out further, and then the other one kicks it down so that it gets a good coverage. I've never seen a vertical sidewall. Recess pendant, there's lots of those. They look nicer. They recess up. They give you some extra inches where the other ones didn't. Recess pendant, that type of a frame is where they got the term harp from, the frame or harp. And again, it's a pendant hanging down, so you'll see that there aren't any fingers on it going up. They're all aiming or set so that the water hits them and sprays out, and gravity makes them fall down. I've never seen a concealed horizontal sidewall. I've seen many concealed pendants. The whole idea of a concealed pendant, and I'm guessing the sidewall works the same way except it uses the water pressure to push it out. But this is a pendant concealed. The picture on the lower right is what it looks like. It has threads on the base that screw into the piping, and then it has that little screw shroud around it, that little can. And then it has a set of rails, and on those rails is a the little deflector disc. And the upper left one shows it upside down, and you'll see gravity causes it to fall back into the can. And to keep it from falling down, they have a special lid on it. That brass or copper thread combined with the white cover. The white cover is soldered in 3 places to the brass threaded portion. And it screws up into that can where the rails are, and it holds it up there, keeps it from falling by gravity. When a fire starts, the solder on the lid melts sooner than the sprinkler is rated at, so that will drop off sooner as the heat builds, and that allows the deflector disc then to drop down on the rails and be ready for when the bulb fractures and then water comes pouring out. It's a pretty neat idea. It's pretty safe, and the nice thing is it gets everything out of the way, and I've never seen one of these damaged unless a whole area of a seating was damaged from some reason. This is a factory mutual, an FM rated sprinkler. There's no UL on this one. Code says that you have to use listed devices, and this is listed with factory mutual, so you can use it. But if you look at the information stamped on the deflector disc, you don't see a whole lot of information. You see the temperature and the model number, and that it's FM rated, and that's it. UL goes much further. Because of that, what they require, they meet the FM, and then they exceed it. And so most of the UL ones are also FM ones. However, not all FM ones are UL ones. This is a UL one, and you'll see that it says SPKR, so you know it's a sprinkler. It has the FM stamp. It has the UL stamp. It has a QR. That's a response type, quick response. 68 degrees centigrade is what it's rated at. Quick, what's the Fahrenheit? Well, don't know. Look across, almost 180 degrees across, and it tells you 155 degrees Fahrenheit. Back up by the 68 degrees centigrade, and you'll see 2012. That's the year it was made. There's the model number stamped on it, and there's some other miscellaneous information for sprinkler people. This is an absolute no-no. Never, ever do we want to see this. Somebody has spray painted the ceiling, and in the process they've coated the bulb, and they've sprayed the seal and the whole thing. When you add paint to a bulb, it increases the insulation of that bulb, so the fluid inside will not expand at the rate it's supposed to, and it will have to become much hotter before it finally break. So that destroys the whole rating on it. On top of that, they've had cases where the paint would stick or glue the seal to the pipe, and even the water pressure couldn't push it out. So even though the bulb broke, it couldn't push it out, so water never came. Nothing is to be painted on these things except at the factory where they have to meet UL requirements. And if it's painted in the field, then it has to be pulled out and thrown away. I recommend that if you see something like this in your rounds, that you mention it to the officer, and whatever procedure CCFD3 wants to use, it needs to get back to the business manager owner and point out that, hey, these by code need to be replaced ASAP because your system is compromised and you are liable for anything that happens if these don't work. Or however CCFD3 wants to pursue that. But these are a really bad no-no. Same thing with smoke detectors and so forth, and heat detectors. You're not supposed to paint them at all, and if you do, they're supposed to be replaced. This link, which probably won't play in the video, but if you copy it and put it on, it's high rack storage, and it shows what the large droplet sprinklers can do in high rack storage. And if you watch it all the way through, it's about 10 minutes, you will see that even the one with the sprinklers still has flame going underneath, And that's why they say that it suppresses, but it takes the firefighters to completely put it out. And that is the expectation on these systems. They are not a fix-it-all, but they're just to try and hold the fire back so it makes it easier and much safer for the firefighter. On the left is a regular half-inch sprinkler head. That's the standard in the office and so forth. On the right is a 3/4. That's the smallest of the large drop sprinklers. They're used in high rack storage, and they have a slightly different intention. Since you have high rack storage and things are above other things, and so they act like umbrellas, they don't spray out as far, but they pour tons of water, and what they intend to do is to soak the boxes, the pallets, the merchandise from the top down so that the fire doesn't climb up. And the hope is that it will hold the fire down on the lower racks or come close to putting them out. And if you watch the video, you would have seen how effective that is. These are different versions of the large drop sprinklers. This is a strange critter. Even the industry gets confused on this. There are wet pipe sprinklers and there are dry pipe sprinklers. A wet pipe sprinkler is a sprinkler that can have water up to it at all times and not flow water out the sprinkler. It can be all the way up to the seal or plug at the end of the sprinkler before the deflector disc. A dry pipe sprinkler has its seal recessed way in the back. Now the hand drawing up here at the blue and the yellow, they don't turn like that. Actual pictures are on your left, but you can't see the intent there. But the intent is that on the copper threaded end, that's where the seat seal is. And it has a long rod that comes up from that to the round disc that the glass bulb holds back. So when the bulb breaks, that shaft is spring-loaded and water pushing it, and it pushes out, and water flows around that and comes squirting out and is sprayed. Now remember, a sprinkler is the actual head, not the system. So a dry system has air compression in the dry part, and that has to bleed off before water fills in. But the sprinklers in a dry system can be and usually are the same sprinklers as in a wet system. These are not the same, but quite often a dry pipe sprinkler is confused with a dry system, even by the workers and technicians. The problem with that when they make that mistake, and I've seen it many times on their reports, their dry system needs to have the sprinklers laboratory tested. So they need to pull 10% for a sample and send them in to see if they pass. Well, if it's a dry system, no, they don't, because they have the same sprinklers that the wet pipe does, and those are either 20 or normally 50-year test points. The dry pipe sprinkler itself is required to be tested every 10 years. And if not properly maintained, they can be dangerous. When I was at Central Kitsap Fire and Rescue in 2008 Halloween, we had a apartment complex that jack-o'-lantern fell over. The candle caught the vinyl siding on fire at 1 o'clock in the morning. 2 teenagers saw it. One of them called the fire department. The other one grabbed an extinguisher and put it out. But there are 4 families that were trapped on the second, 2 on the second and 2 on the third, because the stairs were exterior and each landing was shared by 2 apartments. And the apartment that had the fire was the 2nd floor, and it was already into the stairwell and you couldn't get out. And these things didn't work. Well, when the battalion chief, that's who CK uses for their duty shift chief, came in and saw me the next morning. He dropped 3 of them on my desk and said, "What's going on?" And I looked at them, and the inside of them were green. And so when the other inspector came in, we threw everything we had at it and doing research and everything else. Bottom line, this particular brand and model have been recalled 3 times nationally. None of the sprinkler people locally put 2 and 2 together that they had that. They weren't doing their job. And on top of that, they were banned in the state of Virginia because they had had 2 fires that people had died because these didn't activate. We almost did. If those 2 teenagers hadn't been out in East Bremerton at 1 o'clock in the morning, who knows what would have happened, because these didn't work. So we went over it with the owner, who then called his sprinkler people, and they acted like they didn't know anything about it. So he got a different sprinkler company that said they did know about it. And he went out and changed 282 of these things. Now, when they work, they're an excellent tool. But when they don't work, they can be devastating. But they are a dry pipe sprinkler, not to be confused with a dry system that has dry pipes with an air compressor to keep them dry. In this slide, you'll see, follow the red arrow, that is where they're at. The whole idea of these things is that the head, which if water is there, will freeze in the outside, doesn't have water. Instead, it has it inside, and that's why they're different lengths, because depending on where they run the wet system line inside through the apartments there, that's how long they need that shaft, so they can push this through the wall and screw it in, so the water is kept on the warm side, and the cold side doesn't have any water unless the dry pipe sprinkler fuses and calls for water. But when they're in good working condition, they're great. But like so many things, if they're not in good working condition, they can be devastating. And unfortunately, that's been a real frustrating push, especially in swim. It means money to do these things, and people just don't want to spend the money. They don't see the value in it until something bad happens. So we've pushed, and some of them, 2 companies are now pushing it also, and they write it up at least, and then I have ammunition to go out and say, look, they've written it up, you've been given written notice, the liability is now on your head, and we have to forward this on to the state and to your insurance company, and they usually go take care of it immediately. Miscellaneous appurtenances. I struggle with that word. My tongue doesn't like to bend over backwards. But what are they? Well, they're actually all the little superfluous odds and ends and pieces and things like that. Here's one. Any idea what this is? Any idea what it does? Well, it's a low point drain, also known as a drip drum. It's only needed in locales or geographical places that have freezing weather at times. What happens with a dry system is your compressor pulls in outside air, which includes the precipitation sometimes, just the moisture in the air, and that condensates out and flows down to the low point in a dry system. And if you don't drain it off, then it freezes during the winter, and then when it unfreezes, the water starts to flow, and we get a false alarm. System has to be shut down until it's repaired. So again, decades ago, scores of years ago, they came up with this idea. On top of the drip drum, and this is the drip drum in the middle, it's the fat part called the drum, there's an upper valve, and you keep that open to keep the air going down to the drum. And the idea is the condensate will then run down the pipe and fill up the drum. You go out and you close the upper valve to keep the air in the system, and you open the lower valve to drain the system, to drain the drip drum. And so all the condensation and the moisture go out, and a little bit of the air. By the way, some of these have a plug in the pipe at the end where it discharges, so you always want to take that out if you're doing this work. But once it's drained, then you close, in this case the orange handle valve, you put it back in this position, close, and then you slowly reopen the yellow valve to this position, which is open, and now we'll continue. And if the slopes are right on the sprinklers, so that the condensate will run to the low point, then this works wonderfully. But some places, which we discovered at Squim Community Church on their social hall, the northwest corner seems to have a low spot. And when we have a hard freeze, it freezes. And their maintenance people have said that, no, they are doing this, and they don't understand. Well, the only reason would be a low spot so that doesn't get drained and the water sits there and freezes. So they were working on that the last I knew, a year and a half ago. Hopefully they've got it fixed. Anyway, that is a low point drain, also known as a drip drum. One of the interesting problems we've had is the blockage of access to sprinkler systems. This is at a place that I'd inspected about 6 months before, written them up for having a file cabinet and stuff piled in front of it where you couldn't even see it, written them up for not having nameplates on the valve, on the flow switch, the other stuff, not having a sprinkler room sign hung on the door from outside in. I got a call from A Shift, and Captain Swanson wanted me to come down and take a look. They'd had a fire in a golf cart, burned up 2 golf carts, took out 2 sprinklers. They couldn't find the shutoff valve. And so I came down there and saw what they were doing and took them in here, and the electricity was shut off, so with flashlights, but no sign, so we didn't know. And you just had to know where it was. And since I've been there, I did. But the bottom valve is the shutoff valve. The red box is the flow switch, and that little gauge on top is the pressure switch. And as you can see, it's at 0 right there because they'd shut the water down with the valve once we found it. They also added a garden spigot, which is a no-no. However, this is at a golf course that is not within the AHJ of the city or the county, so there's nothing that we can do. I told them again that we needed to do that, and when they had their second golf cart fire in a different building, 18 months later or whatever, they still hadn't had it done, and now they have a whole new building and new golf carts, and hopefully the stuff is done right. But again, we're not allowed in except by invitation, and therefore I don't know what the status is. This is a 5-inch stores FDC, along with the 5-inch stores on the main port, the steamer port of a hydrant. We tried to do this. I say we, as CCFD3. This started with an effort by Fire District 3 over a decade ago. I'm guessing probably 15 to 20 years ago. And they got a grant and they went around putting these things on and replaced them as far as they could go, and they did a good job. There are still some that do not have these, but most of them do. And one of the things that we've been able to do was to get through the city code that this is what's supposed to be put on all of them. So all the new stuff are supposed to be getting this if we're monitoring it and reminding the city that's what we need. This is out in front of Michael's and Ulta, but it is not theirs. Theirs is behind the building, and Home Depot and Petco, most of those are behind the buildings. This is a good complex to do a tour of and just take a look and get familiar. This one is out in front. I think it's the other beauty salon. It's either that or the tire place. I don't remember which. This is another FDC on a building that with the stores, the 5-inch. This is the old Siamese, 2.5-inch Siamese FDC. This hinge is right there in the little dent in the lid or the cap. That's the hinge pin for a flapper gate. And if you hook up to one side, then the gate swings to the other side to keep the water from going back out that way and puts it into the sprinkler system inside. And if you open and put the other one on, if you have them both on, then if it's equal pressure on both sides, then it basically stays in the middle and it takes as much as you can give. Now it looks like that might be fun to open. It's so corroded and stuff. This is a fairly new one, nice pretty brass. No caps. That's a bad thing. But it's also very common. This one's not in our district, but again, no caps. I have found empty soda pop cans They fit perfectly inside these things. I have found birds' nests, some with birds and baby birds, and some with eggs, and some just the leftover nest. Worst I found was yellow jacket's nest, and when the hornets came flying out at me, that gave me a bit of excitement that day. But they had to completely back flush the entire system to blow it all out, and then I made them run a camera down it to make sure it was clear. And the suppression technician made the comment that, well, he had meant to put the caps on, he just forgot to. So there's no telling what the issues are, but these brass things, I'm surprised they're still here. They've been very common to take a Sawzall, cut them off, and then sell them as scrap metal. Now this picture is unique. I've had more questions about this one particular item than any other, I think, in SQUIM. This is not an FDC. I want you to take a close look at this. It's on the left, and if you look at the cap is female threaded onto, which means it's got to be male thread on the port. Where an FDC, the port is female threaded, and the hose you screw into it has to be the male end. They're done that way deliberately because the strange little object on the left is actually a test equipment for the fire pump at the back of Home Depot. Besides having a check valve in back of this, or inside the building on this system, you don't want to open these, because if you open these, then your water pressure will start discharging. The fire pump systems will sense that, and they will kick the fire pump on full bore. What they do with this is the NFPA requires that it be tested in 7 different levels of flow. Churn, which means dead-ended, 25, 50, 75, 100, 125, and 150% of rated flow. So the technician is supposed to come out once a year. He takes the caps off these. He hooks hoses up. Hose Monster is what they make one specifically for this. And they put it out back, and then they start the pump up before they open any valves. And when the pump is running in the churn state or deadhead, they take voltage readings on all phases. They take amperage reading on all phases, and they log it. And then they come out and they open one of these, and that's 25% flow. And each one of these is 25%. So you go from all of them closed equals churn or deadhead, and then you open one is 25, then 50, 75, 100, 125, 150% of rated flow. All of that is to be documented to show that the pump is working. It's not getting old and drawing too much current, which is going to burn up when needed. Just that everything's working. So don't play with this. Don't even mess with it. It's not something you want to mess with. You can cause a lot of problems. That basically covers the presentation. If you have any questions, please contact your shift officer. And with your shift officer's permission, you can contact me. I have no problem answering questions. I don't charge firefighters for any questions they ask. And I've relayed that to Chief Hudson. But I want you to go through your shift officer first. Most of them have been through this. They're all very sharp. Please talk to them, have them lead you through. If you run into a question that nobody can answer, I will give it a try. And if it has to do with fire alarm or fire suppression, I think I can do that. But please go through your shift officer first. So 2 things. 1, try to learn something new every day of your life. And 2, be safe out there.